As today, October 9, 2025 unfolds, the crisp autumn air carries with it a familiar question. What will this winter be like? For the upcoming winter of 2025 to 2026, the answers are far from simple. We stand at the intersection of prediction, where long-held traditions meet the cutting edge of atmospheric science. This creates a fascinating and important clash of forecasts. On one side, we have the venerable almanacs, which have guided generations with predictions rooted in historical patterns and celestial cycles. They offer a broad, sweeping story for the season ahead. On the other side, we have sophisticated computer models, the workhorses of modern meteorology, which process vast amounts of current data to project future weather. This program will delve into this forecast clash for the winter of 2025 to 2026. We will carefully compare and contrast the different outlooks being presented. The goal is to understand not just what each source predicts, but why their conclusions sometimes diverge so dramatically. We will explore where these seemingly opposite viewpoints find common ground, revealing a more nuanced picture of the potential weather ahead. By breaking down complex science into simple terms, we can appreciate the challenge of predicting months in advance. Most importantly, this is a practical guide. 3 plausible scenarios, clear signals to watch, and steps to prepare. To understand differing forecasts, we must understand the forecasters and their tools. Traditional almanacs versus modern seasonal forecast centers. The almanacs have centuries of history and a proprietary blend of methods. Historical data, solar activity like sunspots, and lunar cycles. They lean on the idea that weather patterns recur in cycles. Their forecasts are made far in advance and remain static, a single confident seasonal narrative. Modern forecasters use physics-based models, massive programs simulating the atmosphere and oceans, updated with real-time observations. They ingest oceans, ice, pressure patterns, and the upper atmosphere. The output evolves as new data arrives, weekly or monthly. A key presentation difference: deterministic versus probabilistic. Almanacs speak with old-fashioned certainty, while scientific outlooks express odds, acknowledging uncertainty. The climate system is chaotic. Probabilities reflect a range of outcomes. They emphasize different drivers: solar cycles for almanacs, ocean patterns, especially ENSO, for models. Ocean temperatures reshape global circulation. El Niño often brings a milder, wetter south. La Niña can tilt colder in the north. The polar vortex and jet stream position are critical and hard to predict months out. Strong vortex, cold stays north. Disruptions, cold dives south. One blocking event or storm can flip a month's character for a region. Hence, models give probabilities. Almanacs give a single narrative. This philosophical divide, cycles versus physics, static versus dynamic, drives the annual forecast clash. The almanacs lean toward a return to a traditional, challenging winter. Large portions of the United States could see colder conditions than recent years, with emphasis on the central and eastern two-thirds of the country. Not uniformly cold. Expect several significant cold snaps lasting a week or more. They also hint at above-average snowfall in many of those same regions. The Northeast, the Great Lakes, and the Upper Midwest feature prominently. They favor powerful coastal storms, nor'easters, targeting major eastern cities, and a steady cadence of clippers for the interior. Their rationale: solar signals and historical analogs pointing to weaker westerlies, allowing more Arctic air intrusions. A blocking pattern near Greenland could force a deep jet dip, fuel for snowstorms. These are broad strokes, not day-specific storm calls. Their message: prepare. Check heating, stock fuel, ensure snow equipment works. Respect winter's power. Be ready for a more formidable season than recent years. The model perspective, often milder and more nuanced. Early autumn runs suggest a milder than average winter for much of the U.S. Many do not see a strong La Niña. Key regions are neutral to slightly warm. That setup favors a zonal jet, keeping the harshest cold contained north. Above normal temps likely across the southern two-thirds, with shorter, less persistent cold bursts in the north. But disagreement among models is notable. Confidence is lower than usual. Some show a split flow, implying a variable winter. West milder and drier, east a battleground of air masses. Expect mixed precipitation types along recurring storm corridors. Even a mild winter can feature a short, intense Arctic outbreak. Despite the clash, both sides agree. The winter won't be monolithic. Harsh in one region can coincide with mild and dry in another. High-impact isolated events can define a season, even in a mild year. Coasts behave differently than interiors. Ocean influence tempers extremes. Ultimately, both camps focus on the jet stream and large-scale drivers. The same puzzle, different tools. Synthesizing the signals, 3 scenarios emerge. Scenario 1, the classic Almanac winter. Weak vortex, wavy jet, blocking near Greenland. Extended cold spells and above-average snowfall. Nor'easter risk high. Scenario 2, split flow, ridge west, trough east. Frequent swings and mixed precipitation. Scenario 3, zonal mild, strong vortex, fast jet, storms quick and mostly rain for big cities. The most benign for travel and heating costs. Watch the ENSO signal, El Niño, La Niña, or neutral, our strongest driver. Early season jet behavior matters. Wavy favors colder, flat favors milder. Rapid Siberian snow advance and low autumn Arctic ice can hint at a weaker vortex. Look for model consensus, not a single dramatic run. Prepare for a range. Small steps now pay off later. For a colder outcome, insulate, service heat, ready snow gear. Keep a vehicle kit for winter surprises. For volatile patterns, stay flexible and check forecasts often. Even mild seasons can have isolated high-impact storms. Don't be complacent. Maintain a basic home kit. No alarm, just practical awareness for winter 2025 to 2026.